Hi, Division 25. Today I'm excited to share with you all some of my recent work in the area of visual analysis. Visual analysis is the primary form of data analysis for researchers using single subject design. Unlike statistics, where there are objective criteria for determining significant differences, visual analysis uses fewer formal rules and often relies on contextual information. This has led to some critique that visual inspection, being somewhat subjective, might be an unreliable method for interpreting data. Because of this potential subjectivity, researchers have looked at consistency amongst expert raters when evaluating graphs. This research broadly supports that visual analysis is often reliable, at least with reversal designs and experts, but the use of visual analysis in other designs has been evaluated far less frequently. Multi-element design may warrant particular attention for a few reasons. Their use is exceedingly common. They involve comparing data in simultaneously displayed conditions, and they often include multiple test conditions compared to control. Thus far, research has not systematically evaluated the reliability of expert raters in interpreting multi-element data, at least in the same manner as it has with reversals. The purpose of our study was to further evaluate inter-rater reliability of multi-element data on both a dichotomous yes-no, so does this show experimental control or not, and a continuous 1 to 100, how confident are you, scale, and to evaluate new variables common to multi-element design. The 4 variables we manipulated were number of test conditions elevated, mean shift, and variability. Here are a few examples of what our 33 constructed graphs looked like. Our 17 participants were then presented a short vignette that basically said, we're going to show you some graphs. Please tell us if they demonstrate experimental control and how confident you are on a scale of 1 to 100. All right, so let's dive into our results. We're going to start with our dichotomous yes-no responses. This shows the number of graphs by percentage of agreement. So if all raters agreed all the time on the presence or absence of experimental control, we would have 33 graphs at 100%. As you can see, we're not that far off from that and had no graphs under 75% agreement. All right, on to our 100-point scale. This graph shows each individual graph's mean rating and error bars indicating the standard deviation. So respondents used the full scale of 1 to 100, not just yes, it shows experimental control 100 and no, it does not 0. There's also less variability in responses when the mean was closer to 0 or 100. Additionally, our statistics showed high levels of agreement for both our yes-no responses and our 1 to 100 scale. So overall, across all manipulations of mean shift, behavioral variability, number of test conditions, and number of effective or elevated independent variables, respondents agreed on the presence or absence of experimental control 97.1% of the time. And our ratings on our 100-point scale were highly correlated as well. To conclude, across our 33 figures that included manipulations of variables common in multi-element design data, expert raters were consistent when implementing visual inspection. This finding impacts our field by adding to the growing research base, showing that despite the opportunity for visual inspection to be subjective, it can be a reliable tool for single subject data evaluation. Thank you.